Hudson Gilmer, CEO of LineVision. Thanks so much for joining me today. It's great to see you.
A pleasure. Good to meet you, John.
Yeah, good to meet you too. And I'm really excited to dive into this dynamic line rating project that you just completed with National Grid New York, which, according to the press release, is the first in the state and the largest in the U.S. And we'll unpack that a bit more here in just a second. But can you start us off by breaking down dynamic line rating technology, DLR, before we get too far ahead of ourselves, and also this broader context of grid enhancing technologies?
Sure. I'll start broader. Grid enhancing technologies really encompasses a set of sensor and power electronics technologies that help utilities get more out of their existing grid, really optimize the grid that we've already built and have invested in over the last 100 years. Dynamic line ratings is one of those technologies, probably the one that gets the most attention these days, candidly. And really what it does is help utilities move from very conservative, I'll call them blind assumptions about how much power they can safely flow through their transmission lines to using sensors to monitor actual conditions and take advantage of the fact that in most cases, in 95+% of the time, conditions are actually more favorable than those worst case assumptions that the static ratings are based on would suggest. So for example, even a relatively small amount of wind, 3 feet per second of wind perpendicular to a line, cools it enough that you can safely put over 40% more power through that line. So by essentially what we're doing is building grid capacity in a new way, using sensors and technology rather than poles and wires to build grid capacity.
Can you round out that suite of tools that do exist within this category of GETs, as we call them, grid enhancing technologies, and why DLR is maybe more ahead than others?
Sure. Maybe the easiest way to think about it is using a traffic analogy. So you think of the grid as this interlocking kind of meshed connection of roads or transmission lines. One technology is what's called power flow control. And this you can think of as really a smart traffic light that helps balance loads, helps balance the flow of traffic across multiple pathways on the grid. A second is topology control, and this is a software-based solution that helps drivers or helps grid operators reconfigure the grid to route around accidents or route around congestion on the grid. It's almost like a Waze or a Google Maps for the grid. And the third is DLR, dynamic line ratings, and this is like adding an extra lane to each of those roads. So just unlocking more capacity. And it's, I would argue, the most, I'd say, universally deployable solution, but these are all complementary solutions, not really competitive.
So talk to me about the National Grid project. How did that come together? How does it work? And what do you think is one of the bigger takeaways on being able to deploy a project like that at this kind of scale with a such a respected player as National Grid?
Sure. So as you probably know, New York has some of the most ambitious climate goals in the country. Their CLCPA, the Climate Leadership and Community Protection Act, calls for 70% renewables powering the grid by 2030, which frankly is not that far away, and a fully net zero grid by 2040. And it goes on, they commissioned a New York power grid study that identified where the bottlenecks on the grid are that are curtailing renewables, that are preventing more wind and solar from being connected to the grid. And that was in many ways kind of the genesis of this project, because a number of the lines that we deployed on were designated CLCPA lines or constraints. and so National Grid chose, and that power grid study actually specified DLR as a technology in the short term that could help alleviate those constraints. So National Grid, could have just gone business as usual, but they chose to really lean into this technology, and they deserve most of the credit here. It's not an insignificant undertaking. This is more than just a pilot project where, say, it's an R&D group that's kicking the tires on the technology. This is saying, no, we're actually taking the data from these DLR platforms and feeding it into our EMS, our energy management system, and actually running the grid 7 days a week, 24 hours a day, using that new data. And so this has been a project of updating methods and procedures for their control center operators. It's doing the systems integration. It's updating the EMS software. It's going through the security analysis to make sure that this doesn't pose any risks from a cybersecurity perspective. And ultimately, it's also integrating with the system operator, with the New York ISO, so that when they run their power flow models for the day ahead or the real-time markets, they're using those new dynamic line ratings. So it's a major undertaking, but the benefit is huge to their customers, to their ability to scale their system and connect new loads. It's got a great consumer benefit because building capacity in this way is much cheaper for consumers than building new lines. And it's now that they've done this operational project, it's a tool in the toolbox so that when they see other constraints elsewhere on their grid, they can use this technology without having to go through the same heavy lift.
Can you give me some of the specs around how big of a project this is? How many maybe miles of line that you installed sensors on, the software that you had to integrate into National Grid's EMS system? How big is this, being the largest deployment in the U.S.?
Yeah, so this was 4 lines. So it's still, frankly, it's a relatively small percentage of their overall system, and we're still in the early innings as an industry of deploying dynamic line ratings. And I fully expect that in less than a year's time, we'll be breaking our own records in terms of being able to announce ever larger projects. But it's still significant, right? This is a fairly highly congested part of their system with a high concentration of wind farms and solar facilities upstate in Western New York. I think they quoted fairly significant, I don't have the numbers in front of me, but numbers of megawatts of generation that can now be connected to the grid as a result of these projects, and curtailment that can be avoided.
How do we ensure that National Grid and other transmission developers, owners, utilities realize and adopt the benefits of GETS? What's in it for National Grid to find that additional capacity on their system, as opposed to rate basing a new infrastructure investment, in lieu of whatever may come from FERC as they get more and more comfortable with GETS? And we'll get to that in a second. But what's in it for them, and how do we make sure that they're incentivized properly?
It's a really good question. I mean, I think National Grid is doing it for the right reasons. They feel like they have an obligation to serve their customers and look first to get the most out of their existing wires. And they don't see this as an either-or proposition. They may, in 5 or 8 years' time, need to reconductor these lines because they're just seeing so much load growth on their system that the longer-term solution requires a more fundamental upgrade of the facility. But this is the right solution for now to alleviate those bottlenecks. The other thing I would say is that we're in kind of a brave new world in this industry where utilities are seeing load growth that they haven't seen for the last 20 years. It's driven by electrification. It's being driven by onshoring of manufacturing, a lot of which is in upstate New York. It's being driven by AI and new loads on data centers. And so utilities are very motivated to say, how can I make sure my grid is able to support the challenge of connecting those new loads? If we were still in a period of flat load growth that we were in until maybe a year ago, I think it might have been a little more of a challenge to get utilities excited about deploying these kind of technologies. But now I think there's going to be winners and losers. There's utilities who have invested in these technologies and are positioning themselves to be able to connect new loads and not say no. And they're the ones that are going to attract these coveted projects.
And is this the most expeditious solution when dealing with congestion and curtailment in some of these high renewable energy, penetration zones, as opposed to, you mentioned reconductoring, which I imagine is much more expensive. We know that new transmission build out does not only face the permitting and siting headaches, but it costs a lot of money. So is that how you view this in the stack, as this is kind of that first step to addressing that problem, and then you can move on to reconductoring in greenfield?
Exactly. This is the low-hanging fruit, right? This is the least regrets solution that can be deployed in a matter of months, as opposed to even reconductoring often requires engineering studies and permitting and in some cases tower rebuilds, and that's a multi-year process. As you said, building new lines can be 10 or more years, if it's not blocked by NIMBYism or permitting issues. So this absolutely is by far the cheapest and the fastest way to alleviate those issues.
And you mentioned too that even if reconductoring is ultimately in the plans 5, 10, 15 years down the line, that doesn't mean we can't also take this step first in the interim. Is there even a ballpark general kind of payback period that you reference when you're talking to folks about if you install this and still go forward with reconductoring or new build, it's not just a sunk cost?
Absolutely. DOE did a study actually looking specifically at New York and showing the consumer benefits, the ratepayer benefits of grid enhancing technologies, and showed that for traditional infrastructure projects, the payback period is roughly 17 years, 15 to 17 years. Whereas the payback on DLR and other grid enhancing technologies is as little as 6 months, between 6 months and 2 years. So it's incredibly compelling.
So we're expecting, I mentioned FERC, and they play an important role in all of this. So we're expecting some major rulings from FERC on transmission, and more specifically interregional transmission development, early next week. And commissioners have discussed in the interconnection ruling FERC Order 2023 the desire to incentivize GETs for more efficient deployment throughout the country. But ultimately, within that order, it's my understanding they only required planners to evaluate GETs as part of the process. They did not mandate that grid enhancing technologies are deployed. Commissioner Christie wrote, and I'll read this from his concurrence: some GETs work somewhere, but not everywhere. Some work sometimes, but not all the time. Some only work under certain weather conditions. Some don't work at all, or at least not as advertised. And some are only cost effective where the congestion costs are greater than the cost of the GET itself. Now, he did also mention that DLR is something that he's excited about and thinks is ready for this primetime role. But interested in your response and framing of that. He was clear in saying we should not mandate that planners deploy GETs.
Right. So I've been in this industry a long time, and this feels like deja vu. If you go back 20 years, the same arguments were being used to say we can't plan for wind and solar because we can't forecast whether the sun is going to shine or the wind is going to blow in 5 years' time or 10 years' time. And similarly, I worked in the demand response industry, and we were looking to have a level playing field with in the capacity markets with generators, and the argument was, you need iron in the ground, you need that firm dispatchable source of capacity, and can't trust on demand side solutions to show up. And the proof is, in the pudding. We as an industry have learned to use stochastic methods to plan for wind and solar, acknowledging that they are intermittent and we can't run the entire grid on them. And demand side resources are playing an important role in the capacity markets. And we'll see the same thing happen in terms of the evolution of dynamic line ratings in grid planning. I think, what I would say is that we're working with 7 of the largest utilities in the country right now. They're currently seeing tremendous benefits in the operational timeframe, say 0 to 5 years. And it'll take a little bit longer for this to spill over into regional planning processes and having them updated to fully incorporate grid enhancing technologies. But it absolutely is going to happen, and it's happening very quickly.
I should have asked you this earlier when we were talking about the grid project in upstate New York, but what, if any, kinks did you have to work out in deploying a project kind of first of its kind at scale like that? And what did you learn maybe from that project specifically that you'll take into some of these forthcoming efforts?
What I would say is that each line is different, and we learn a lot, and our customers learn a lot when we reveal data that they've never seen before on these lines. In many cases, they're operating the lines. There's been a lot of consolidation in the utility industry. These companies have merged, and assets have moved from one company to another, and sometimes the assumptions about the assets are very different from what we actually observe in reality. And so there's been real learnings about what actually is the performance of these lines, which in some cases is quite different from the assumptions going into it. And I think what was exciting, I was in Syracuse, New York at their control center several weeks ago, talking to some of the operators, and the feedback is we love the visibility that we're seeing on these assets, not just the ratings, but if there are any anomalies, kind of unusual behaviors on those lines. And now we're seeing it on 4 lines of our system, but it's also revealing what we're not seeing on some of the other lines. And so I think there's potential for this to really become kind of industry best practice to say, let's give utilities, let's give the operators of these grids the best possible visibility into these assets.
Yeah, I can see a huge advantage for one of these holding companies, an Avangrid, or pick your Exelon, whoever, that has that visibility broadly across all of their portfolio companies. I imagine that would make the decision making process at a corporate structure much easier than blindly saying, here are the specs that we were given from the manufacturer 60 or 70 years ago.
Exactly. And one of the other things we can do is show them how the current performance of those lines compares to the original specs. So we can show what the what's called sag temperature relationship is of those conductors, and detect if a line that's been hanging in the air for 70 years through a whole lot of extreme weather and maybe wildfires burning underneath, is it still safe to operate? How close to the end of its useful life is it? Has it experienced plastic deformation that may cause loss of strength, et cetera?
So there's a bit of debate around GETS in whether it's part of the planning process or whether it falls into the O&M bucket. Who, in your opinion, should be responsible for deploying the technology? Is it planners? Is it regulatory mandating that they're incorporated into the process? Or is it transmission owners after the fact with their existing assets saying, I know that I can unlock X megawatts of capacity on these lines for this cost instead of building a greenfield or reconductoring? Where does that land? Maybe it's a mixture of all of them, but I'm curious what you think.
Yeah, I mean, I think ultimately it is the TO, it's the transmission owner and operator who is responsible for the line ratings, and but they don't operate in a vacuum, right? They're subject to their regulators at the state level and at the federal level, and they need to be responsive. So I feel like this is, some people try to make this out to be, that utilities are digging their heels in and saying, we don't want to do this, and don't make me do it. I really do believe that there's a tipping point where it's a win-win. It's good for the utility because it allows them to operate their grid more safely, more reliably, more efficiently. It's good for their customers because it's the least cost way of building grid capacity, and that means it's also great for the regulators.
Hudson Gilmer, thanks so much for joining me today.
My pleasure.